Welcome back for the video for 7.1. This chapter, we're going to work on just two lessons. The first lesson is over the law of sines. It's going to help us solve sides and angles of triangles that are oblique. So these triangles do not have a right angle. So we have to use some other strategies. And so in 7.1, we're going to learn about the law of sines. And my pages might look out of order, but the numbering's correct. So the law of sines says that if we have a triangle that does not have a right angle, triangles A, B, and C, then the following ratios will hold. Side A is compared to sine of angle A as side B is compared to the sine of angle B as side C is compared to the sine of angle C. We can also write them as the reciprocals as well. So it depends on what you have, may be more useful to write them in a different one way or the other. So the three situations we can have to use the law of sines would be angle side angle, where a side is common to the two angles. So that would be this figure 4 right here. Side, angle, side. I'm sorry, angle, side, angle. The side is enclosed between the two angles. We could have angle, angle, side, where we have the one side that we have is opposite one of the angles. Or we could have side, side, angle. Okay, so side, side, angle could have some extension situations, and we'll go over those in a minute. So let's just do look at a couple of examples using the law of sines. And example 1, they want us to make sure you know all three angle measures and all three side lengths. So in this example here, we have angle, angle, side. So this is angle, angle, side, just so we know what we're working with. So we have side A over the sine of A equals side B over the sine of B, which is 40 degrees, equals side C over the sine of 120 degrees. Now, because we know two of the angles, we can find angle A just by subtracting. So 180 subtracting 40 subtracting 20, we know that angle A is equal to 20. So that's done. So that's 20. So now we just need to find the sides of A and B. So using our proportions and ratios, oh, wait, we know this one. I forgot. We know side C. So because we know this complete ratio here, 10 is compared to sine of 120, we can use that to find the sides of A and B. So if I multiply the right here, so A is going to equal 10 times the sine of 20, because 20 is the angle A, over the sine of 120. And if we type that into scientific Desmos, that comes out to be 3.95 equals side A. And remember, the shortest angle will have the shortest side. And so side B will be 10 times the sine of 40 over the sine of 120. So B equals 7.42. Look at B. So B, we have a side, we have an angle, side, angle. So we have angle, side angle. It's always good to write down what you have here. So we know the sine, so again, we can find angle A by subtracting 25 and 105 to get angle A as 50. So we know that. So our ratio should be 7 over the sine of 50 equals B over the sine of 105 equals C over the sine of 25. So since angle C is the smallest, it's going to be shorter than side 7. And angle B is the largest, so its side will be the longest. So sine 7 over the sine of 50 is going to be the ratio that we're going to use to find the other ones. So side B will equal 7 times the sine of 105 over sine of 50. And when we type that into scientific Desmos, we will get 8.83. And side C is going to be 7 times the sine of 25 over the sine of 50. And remember, this is an individual sine of 25 over the individual sine of 50, not the sine of 1/2, not 25 over 50. So C equals 3.86. Okay, so let's go to the next page is going to be looking at the ambiguous case here. So the ambiguous case is a case for side-side angle. So when you're given two sides and an angle, there can be three situations. There could be the situation where it just doesn't work. And you're going to come up with some sign, the sign of a ratio that is bigger than 1, which we can't have. The sign can never be bigger than 1. So you'll have a no solution. The other possibility is that you have exactly one solution, so only one triangle exists, or you could have the possibility of two solutions. There could be two triangles that will work for the two lengths of the sides and the angle. So let's look at a couple examples here. So we could say example A says we have angle 48, the side opposite 48 is C, which is 7, and B, the side B is 12. Okay, so let's see what the possibilities are here. We have okay. So right now we have A over the sine of A, which we know nothing about. And we have B over the sine of B. And then we have 7 over the sine of 48. Okay. So we're going to use this ratio here to solve for the other possibilities. So I am going to look at this. This is going to be multiplying both sides. So 12 times the sine of 48 equals 7 times the sine of B. So if I divide by 7, we'll have 12 times the sine of 48 over 7. So we would be using the inverse sign here for this. And so we would be looking for the sine of some B ratio would give us this answer. So sine of some angle, would give us this ratio. Let's look at what this ratio is in the scientific calculator here. So if we type in that ratio, 12 times the sine of 48 over 7, it would give us a ratio of 1.2739. And sine cannot be bigger than that. So if we look at the inverse, oops. We look at the inverse sine and put that in there, it's going to tell us that it's undefined. And so we can't define sine. Sine can't be bigger than 1. And so there is no solution to this one. This is one of those triangles where there's no solution. Now the next example is another side-side angle or angle side-side. And we're going to see if there's no solution, one solution, or two solutions here. So we know that we have 7 is compared to the sine of 25, and 9 is compared to the sine of B. And then C, we don't know anything about. So we're going to be using 7 over the sine of 25 to try to help us find the other pieces. So first we have to try to find this angle B because we don't know anything about C. So let's do that. So 7 times the sine of B will equal 9 times the sine of 25. If we compare the ratios. So 9 times the sine of 25 over 7 is equal to B. So we're going to take the inverse of this. Will give us angle B. So let's go to get some practice here in scientific decimals. So again, we're taking the inverse of sine. This time is the sine of 25, 9 over 7. Okay, so our angle is 32.9. Okay. So this is a possibility. So the ratio that we want it to equal is that. So we want it to be 0.544. Well, sine can be 0.543 in two angles. It could be this angle at 32.9, or sine could be that angle at 180 minus 32.9. So it could also possibly be 147.1. So let's write that down. So, and that's because sine can be a 0.543 positive in the first quadrant, and that would be this angle here, 32.9. Or if we take the supplement to that, 180 minus 32.9, we can see that angle sine of 147.1 could also be that 0.543 in the second quadrant. So that's why this one is going to have two solutions. So if we go with the 32.9, we can then find the angle C. So angle C then would be, in this case, 122.1. If angle B is the 32.9 and angle A is 25. Okay, so in that case, then we can solve for side C. So in that case, we know that side C equals the sine of 122.1 times the 7 over sine of 25. And so the side of C would be 14.03. So it would end up being the longer side here. And then the other situation is if B is the larger angle, B is going to be, the 9 will be the longest side. And in that case, we need to find C. So if B is 147, then the angle C will be only 7.9. So then in that case, side C will be 7 times the sine of 7.9 over the sine of 25. Seven. And so the sine will, the length of the side would only be 2.28. I'll show you that on my paper here. So then in that case, so if the angle B is the 32.9, side C will have the length of 14.03, the longer side, because it will be the bigger angle, 122.1. If B is the complement or the supplement, and angle B is the longer or the bigger angle at 147.1, then angle C is going to be the smallest at 7.9 degrees. And we'll also have the smaller side at 2.28. So it has two solutions. And then I've got example 3 has just two different problems that I wanted to give you. And they are here. Zoom in a little bit. Okay. So we have this triangle where we are given this angle here that is supplementary. Supplementary to this missing angle. Then we've got 65 is going to add with this angle here, but we don't know what that is. So because these are supplementary, we do know this angle will be 70. And so that's helpful because then that tells us, let's call this angle A. So then we know angle A will be 180 minus 65 minus 70, or 45. So that's helpful. Now we know this is 45. And so now that we know those three angles, we can help find the sine of H, or the length of H. Because we know 10 is to the sine of 45 as H is to the sine of 65. So H is 10 times the sine of 65 over the sine of 45. So side H is equal to 12.82 in the scientific calculator. And the last problem for chapter 7 here is we have the locations of point C on a small island of the mainland and points A and B on the shoreline of the mainland are shown in the picture. If angle A is 63 and angle B is slightly larger at 76, and we know that A and B, points A and B are 5 miles apart, so we know this distance. Find the shortest straight line distance from C to the mainland. So the shortest distance should be the shorter of the two angles, which would be side A. That's what it should be. So we can find angle C by subtracting 63 and 76. And so angle C is 41. And side C is the 5. So we know 5 is compared to the sine of 41 as A is compared to the sine of 63. So we can find side A as 5 times the sine of 63 over the sine of 41. And so the shortest distance from the island to the mainland would be going side A, and it should be 6.8 miles. Catch me back for lesson 7.2. This is the last problem for 7.1. So catch me back for lesson 7.2 video.